In the last video, I started demonstrating some of the methods on collections, including fill, end copies, add all, and copy of. I'm going to pick up that discussion here, where I left off in the code, with a look at another method on collections that's fun to use when you have a deck of cards, and that's shuffle. I've already got a variable set up called deck that contains my standard deck of cards. I'll cut it from the top of the main method and paste it at the end here. Now I want to shuffle my deck. I could write my own random function to do this, but even easier, I can use the shuffle method on collections. After shuffling, I'll print my deck with a header and in 4 rows. Running this code now. You can see that my deck got shuffled. This is a useful method if you're writing a card game certainly, and a good tool in your arsenal if you ever want to randomize a list of existing elements for some reason. Another method is the reverse method, and it's easier to see what that's doing after the shuffle method, so let me add that next. Collections.reverse passing at my deck. I'll print the deck again. Running this code again. You see that this method simply reverses the order of the elements. The first element in the shuffle deck becomes the last element in the reverse deck, and vice versa. Let's talk about sorting next. You may run across a legacy code that uses collections to sort. There are 2 flavors, much like the sort method on the list interface. One requires your elements in the list to implement comparable, and one doesn't. Right now I'll look at the one that doesn't. The collections.sort method takes your list as the first argument. If your elements implement comparable, that would be it. But if they don't, or you want to force an alternative sort, you can pass a comparator. You've seen me passing comparators to sort in previous videos, but obviously not for the collections class. The same principle applies though. My card record doesn't implement comparable, and let's just say for whatever reason I don't want it to. Instead, I'll sort with a comparator, which I'll set up as a local variable, because I think I may want to use this sort in different scenarios. Hopefully you remember the easy way using the convenience methods on comparator, which let me do this. Var sorting algorithm equals comparator.comparing, passing it a method reference for card rank. I'll then chain the then comparing method to that, this time passing a method reference for card suit. You can see by looking at IntelliJ hints, if you still have them turned on, that I'm getting a comparator with a type argument of card back from those chained methods. Now I can pass my sorting algorithm variable to the collections.sort method. So first pass the deck, then sorting algorithm. Here I'll call card.printDeck with a header specifying how the deck is sorted, but this time I want to print 13 rows. You'll see why in a moment. Running this code now. You can see my cards are now ordered by the rank, and therefore their face value from lowest to highest. This view is a little easier to see that a standard deck of cards contains a 2 of every suit, and so on. Of course, I could have just called sort on deck and passed its sorting algorithm. You might be asking which sort method should you use. To answer that, let me Control-click on sort and bring up the declaration of that method now. You can see that collections.sort calls list.sort anyway. When the sort method was added to the list interface, the underlying code on the collections class was changed to leverage it, to support backwards compatibility of code that still uses the collections class sort. In other words, there's no need to rush out and change the legacy code if you run across code still using collections.sort. I won't change it in this code, but in the future, I'll be using list's sort method. Next, I'll call collections.reverse again, so that my cards are sorted by highest to lowest rank. And I'll print that again, using 13 rows. I'll run the code. And you can see the standard deck sorted by rank and suit reversed. The next couple of methods let you compare sublists to full lists. I'll carve out a couple of smaller lists from my standard deck here, using list's sublist method, and passing them to a new array list constructor. My first sublist will be kings, and since my deck is ordered, I know my kings are in the second row of my last output, so the starting index of the sublist is 4, and the ending index is 8, which is an exclusive index. I'll print this new list in a single row. I'm going to copy and paste those 2 statements. I'll change kings to 10s, and the indices used from 4 to 8 to 16 and 20, because this should be a list of my 10 cards. Okay, running that. You can see I have 2 lists, one with kings and the other with 10s. Now that I have these lists, I can use them to test a couple of other useful methods on the collections class. The first is index of sublist that returns an integer if it finds a sublist in the collection passed to it. The first argument, I'll make the deck, will be searched. The second argument, I'll make that the tens list. This will return an integer if tens is found in the deck, or a -1 if it wasn't. And I'll print the result of that method call. Running that now, you can see this method told me where I could find the sublist in the full list starting at index 16, which we already knew, but this method could be useful if you ever needed to identify if some portion of a list already exists in a bigger list. Unlike contains, the elements in the sublist must be contiguously found in the full list. I'll add contains here next. I'll print contains equals, then call deck.containsAll and pass tens there. Running this now, you can see I got contains equals true, so the list contains all the elements in the sublist. Next I want to shuffle the cards before executing these two tests, so I'll add collections.shuffle and pass it deck on line 59, and running that. You can see the sublist index is -1, meaning the sublist wasn't found in the full list, but contains all is still returning true, so it found the 4 elements. I'll revert that last change and remove the call to shuffle. Have you noticed that IntelliJ is highlighting contains all? If I hover over that, it gives me the message that contains all might have poor performance. The suggestion is to wrap deck in a hash set constructor. Don't worry about this suggestion right now. Obviously our deck only has 52 cards, and I'm only showing you the contains all method in comparison to the index of sublist method. But this hint is a good teaser of things to come. After I finish covering the collections methods, we'll be talking about sets and hash sets. The next method I want to look at is the disjoint method. This method returns true if the two lists have no elements in common. This method takes two collections and returns true if the two collections don't share elements, or false if they do. I'll call this method, passing it my deck and the tens sublist, and I'll assign the result to a Boolean variable I'll call disjoint. I'll print that out. Running this code, you see that disjoint is false. In this code, I'm comparing the full list with just the tens list, and since tens list is really just a sublist of deck, we know there's elements in common, so they aren't disjoint collections. Whether the tens are contiguous or not, disjoint should return false, meaning it found at least one of the elements in tens in the cards list. I'll copy and paste those two statements. I'll change the name of my variable to disjoint2 in that first statement and change deck to my kings list. And in the second statement, I'll change disjoint to disjoint2. Running this code now, you see that disjoint2 is true, meaning kings and tens don't have any elements in common. Now that we've covered shuffle, reverse, sort, index of sublist, and disjoint, I'll end the video here before it gets too long. I've shown you how to use these methods and how they compare, if they exist, to similar methods on the list interface like list sort and contains all method. In the next video, I want to finish up with the last few methods which are included on the collections class. See you in the next video.